Today we'll see what happens when millions of users joins to watch IPL in minutes, and why auto scaling does not works the way it's supposed to. And we'll see the strategies Hotstar has used to solve all of these. Now let's see what this tsunami problem is all about. When Hotstar send notifications of some significant event, let's say Dhoni is coming to bat, so all of his users, millions of users would be joining to platforms in minutes, and we need to scale the platform to handle this load. Recently, Hotstar has 25 million concurrent users. So this is the scale we're talking about. They are saying that legacy backend architecture was not able to handle load after some point. So let's see what actually they have learned and what they have done to solve this. The first thing that we're talking about here is auto scaling, and the limitation here is that it's not effective for the certain spike because it takes time to get the server ready, and the spike that we're talking about here is in millions. Now what they have done, they already have estimated that when will be their peak time, when they will be getting the traffic, so that they can actually scale the system in advance. Now they're talking about something called an headroom threshold. So when traffic reaches a particular threshold, they will be adding the servers in advance. So let's take this example. Let's say we have 1 million concurrent users. So they will be adding 5 new servers, and this 5 new servers is not here to handle this 1 million node. So it's actually here to handle the next 1 million. And when it reaches 2 million, it will actually add next 5 servers, and they are here to handle the next 1 million load. Now let's move to the next point, which is smart clients. So to prevent the backend from being overwhelmed, what they did, they make their client, which is the user device we're talking about, smart. So they decided that the client, the user device that we're talking about, should not be entirely depending on the server decision making. So what they have done, first thing is adding jitters into the client side. So let's take a little bit of an example here. What we are seeing is we have 3 clients here which are sending requests to the server. What we are doing, for every request, we're adding here, let's say 1 second delay, 2 second delay, 5 second delay. So let's say this client makes the request now. After 1 second, we'll be sending this to the server. And for this client, we'll be sending it after 2 seconds. And for this one, after 5 seconds. So they will have some kind of a range, let's say 0 to 10 seconds. Now let's say we have millions of requests coming in. What we're doing here is distributing that 1 million requests over this 10 second of duration. Now let's go back and let's see the second point. Now the second point they're talking about here is caching. They're adding the caching on all levels, including the client side, so that minimum request will be going to the server. Then they have something called panic protocols. Let's see what they are. These are actually strategies to handle the system when it is actually in lot of load. Now, first strategy what we have is something called a graceful degradation. So what we do in that is we reduce the video quality of the live stream. So let's say we have a lot of load actually coming into the server and it is not able to handle it. So what we will do, instead of giving full HD quality to all the users, we can actually degrade it to 720, or maybe degrade it to 720 for all the non-premium accounts, right? And that is the first step. The second thing they're talking about is disable non-essential features. It means, let's say we have an essential feature, that is the live streaming. Something like a live chat is not an essential feature. So if we see a lot of load coming in, we can actually disable all these non-essential features. Then we have something called a back off strategy. The first thing in that is exponential back off, which is like if we are doing some retries in something, we can actually do it exponentially. So initially in 1 second, then after 2 seconds, then 4, then 16 seconds, and so on. Then we have rate limiting, like doing that on the server side, that could be in there. Now let's see some extra strategies they're talking about. One of them is only once. So when we are actually scaling the system on this level, we have to drive away as much as traffic possible from the main server. So what we can do, as we already talked about, something called caching on the server and the client side. And we can also add this TTL on the client side. So let's say we have this client and it's asking something from the server. So it will return it to the client, and client will actually cache it here, and we will add some TTL to it, let's say 10 seconds. So after 10 seconds, it will be actually expiring it, and then it will get it back from the server. And until that 10 seconds, it will actually use this same data which is here, right? Now, so that client does not ask server for everything. That's what we did. Now, the second point here they're talking about is reject early. What they're saying, we have to add good security to filter out the malicious traffic that is coming to the server. Now, the third point here we have is external partner jitter. We already know what this jitter is all about. Now, let's see what we are talking about here. So, sometime in peak time, what happens, because let's say there is an IPL going on and there's a lot of already concurrency in the system. Now, let's say a lot of users are actually trying to make some payment at this time. Now, what will happen, because we are using external payment service, they will get actually bombarded with our requests. So what we're doing here, instead of sending all the requests at the same time, we're adding jitter to the request. So we'll be distributing again the load in some amount of time, let's say 10 seconds. So we can simply spread out the request, allowing higher overall success rate. So what would have happened? The external payment service, if we have sent it all the load at the same time, would not have been able to handle it, and we will have a more failure rate. Then they were talking about something called a watch and play. So they have added some interesting feature. Let's say this online live streaming is going on. They will be having some pop-up where they will have a feature. They will have a game kind of where users will play that game. Like they will maybe have a quiz or something like that. So features they added like a skill based game they were adding. So while watching the live game, something like a quiz will be popping up. Now this will cause a spike in the traffic as we have millions of users watching that game. So what will happen again here, all the requests can go at the same time. So here they have used the golden rule, don't do anything in real time that you don't need in real time. So they will be delegating the task to actually some other service, sending it to the queue. Now can you guess what extra can we do here except delegating the task to some kind of a service, right? You might have guessed it right. We will actually use jitter to again distribute the load in some amount of time, like 0 to 10 seconds or so. Now at the end, they are saying that decrease the streaming latency. Initially in their legacy systems, it probably was 55 seconds and now it is 15 to 12 seconds. And they have tried to optimize every part of their system. Second thing they're saying is they have improved their transcoding logic. In that, they have improved this bitrate by tweaking it. If you want to know more about this, you can actually watch my previous video on Instagram, like how they transcode their millions of videos every day, right? You can watch that. Now the question here is, why is it taking them 15 to 20 seconds? Like the reason is because everything is going on real time. We're talking about here live streaming. So the data will be coming in real time and they have to process it real time. And the data that is coming, it is a lot of high quality. So they have to do a lot of transcoding and a lot of things. Now this is the end of this hotstar blog. I'll be sharing the link of this blog post in the comment section below. And in the next part, we'll be taking a different blog in which we'll learn the scaling policies they're actually using, traffic-based scaling, ladder-based scaling, and then we'll put it all together and we'll see the actual architecture they are following when they are scaling actually their servers. So let's see you in the next video.